And it should also start recording at the same time. Yes. Okay, so let's check if I have everything correct here. Yes, so we are live and we are recording. That's good. I have my mic open, it seems. So we can make a start. So hello all and welcome to the OneClick LCA Construction LCA training provided by OneClick LCA under the Saint-Gobain Architecture Student Contest. So this is the second session and also the last session for the training. Again, couple of training rules. So keep your microphones muted and also ask your questions using the Teams Q&A function. So the chat is not enabled, unfortunately, but you can use the Q&A function to write down your questions. And I will be answering those questions during the Q&A part. So that will be at the end of this session. And if there are several questions and we cannot address all of them, then we will be answering them at the community. So I showed you last time, you can go to community.oneclicklca.com and there, this link that has been attached here in this presentation, it will take you directly to the actual topic of this architecture student contest, and you can post anything related to LCA or the use of OneClick LCA there. These recordings and slides are made available the next working day on the Academy course page. So the first one is there already. So we have the recording there and also the slides. And this is another link to the community. So if you recall, you can click here, the community.oneclicklca.com, and there ask questions and also help out others if they have issues that you can help with. And also you can check the announcements, and also the community is a place where all people from all industries are welcome to interact. So you can also check out all the other parts there and go and see what people are talking about. So yes, not yesterday, sorry, on Monday, we had a session on building LCA introduction, and also we had a short software demo. So we went through also the theory part, so climate change and construction, what is LCA, building LCA stages, and also about data, and then legislation standards. And we also went through how to create the account and access the software. We will be having a short recap on how to access after today's theory part. So today our topic is how to perform building LCA at early stage design. So how do we reduce emissions in practical projects? And then we will have a demonstration of our early stage design tool, Carbon Designer 3D, which should be very helpful when you are beginning to make your designs and beginning to think about all these different steps on how to optimize your design choices. And yes, we will also return to the actual OneClick LCA calculation tool to check out results and how you can interpret them and also use them in reporting and decision making. So let's start with the short theory part. So this is about reducing emissions in practical projects. So when you start reducing buildings' embodied carbon, well, you have to remember that this kind of term, embodied carbon, we already went through what it means. So all the material-driven impacts of a building. So this is a term that is popping up more and more. But what it actually entails might be a bit hazy. So we know that we are talking about these material-locked, material-driven impacts of materials. And these originate from materials production, manufacturing, transport, use, and end of life of those materials. So as we talked about last time, it is a separate entity from the operational carbon or operational impacts that are related then to energy use and water use. So we know that it's critical to achieve net zero and carbon neutral constructions, but how to actually do this in practice. So now we will be discussing some of the most effective approaches. So when we talk about optimizing results, we usually need to start with a baseline. So baseline is our starting point. Here, the baseline is pictured in blue. And then when we start optimizing, when we start making all these different choices to our design, then we can see a reduction in the carbon footprint. So this is the impacts here. So the impacts are at 100, and then with different kinds of optimization steps, we can reduce the global warming potential or the carbon footprint of the design. And here you can see, for example, in this particular case, the bio carbon, so the carbon in biological materials. So this was very small at the beginning, but then it has been increasing. So it is likely that in this particular case, we have been using renewable materials, so wood, for example, or other renewable materials, and these are increasing in share, and this way we can reduce the carbon footprint. For example, it's just one example of this. So in this case, we are creating a baseline building, or we have created one. So this is a study by OneClick LCA that was created to investigate these potential impacts of adopting the different embodied carbon mitigation strategies. And the focus here is solely on practical solutions. Here is also the link if you wish to go and check out the original document. So this has the 10 commandments of reducing carbon. So this is the baseline building. We now see that it's 7,000 square meters office building. It has 7 floors above ground and also 2 underground parking levels. It has a precast concrete frame, and it is assessed for 60 years. And then, before we go into the business, we should remind you that when you begin working on embodied carbon, do make sure that your building has a decent energy performance. So that is the key when you are starting your design, and also that it utilizes whatever low carbon energy supply options your locality can offer. And also, one should pay mind to avoid sites where transport relies on private cars or that have long transport distances for users. So if you have to take your own car to get there, you might want to reconsider the site if it's possible. So these 2 points here provide a solid basis for further decarbonization. So if we go back to our baseline building, here are our 10 commandments, so from 1 to 10 here. And we'll go through these points one by one. And at the end, we'll come back to this graph so you can see what actually affects what. So from here, you can see that we are achieving notable reductions in the carbon footprint. But let's go and check out the points one by one. So commandment 1, do not build for short term, but ensure that the demand supports a permanent building. So optimizing the life cycle impacts for anything less than 50 years is really not worthwhile. So the shorter the service life of building, the more impacts it will have per year. So if we build for 100 years, we have 10 times less impacts per year than we would have if we build only for 10 years, for example, because everything, if it's only for 10 years, the demand is very, very short, and you will be putting a lot of materials there that will be taken away basically after very short time. So the longer the building lasts, the more sustainable it is. So this may be addressed by designing either a building that's highly adaptable or has a modular transportable frame that satisfies the demand for a shorter period of time. So it might be something that you can build, but then it's moved away when the demand is shifting to another place, for example. And in this baseline case we had very big savings. So we started from an assumption that we had 60-year service life versus a 25-year service life. So if it was only 25 years, the annualized material-driven impacts were almost were double. So if the building can be converted to another use, the impact is then reduced somewhat. And then the second commandment is to avoid sites requiring soil stabilization, because the foundations can mean high emissions. So the soil conditions, of course, they impact the stabilization, the foundations that the project will require. And if the site requires massive foundations to support the building, you might want to reconsider the site. So foundations require a lot of material, and usually this is cement, concrete, and steel, which are very carbon-intensive materials. And of course, architects don't really have the means to affect site selection, but you do have the ability to influence the way the building masses are divided on the site. So consider the distance to bedrock, think about the ways to reduce the overall mass to required materials for the to reduce the required materials for foundations, and also avoid cast-in-place concrete, because that tends to have higher impacts than precast products. Yeah, so this is about soil stabilization, and in this baseline case we had, the potential savings were quite high again. So the foundation share of embodied carbon impacts is usually very high. So of course the foundations are not replaced, but if you are considering also the replacements in the whole life cycle, that they make up to about 40%. So for this, and it also notes here that for commandments 2 and 10, we have used a 60-year building lifespan scenario to more accurately depict the impact of each measure. So the 25 years was only for the first commandment. So commandment 3, consider structural options. So could a lighter or timber frame work? So in general, the structural frame is responsible for majority of the impacts, and it should be thus addressed prioritarily. So reducing the mass of frame reduces the need for foundations, as mentioned, and of course the overall material need as well. And here, for example, wood is relevant material to consider. So wood materials require quite a little energy to produce. So for example, for concrete, you would need the excavation of minerals, the transport of heavy materials, the crushing, thermal processing, and the emissions due to calcination and so on. And for wood, you basically need energy only to harvest and transport. And sawmills usually require very little external energy, because you can use the residues such as bark or sawdust to create the heat for drying and other processing. So the emissions there are quite small. And wood is also natural, renewable material. So if you harvest from sustainable forestry, new trees will replace the old ones. And wood is also natural carbon storage. So about half of the mass is carbon that is then removed from the atmosphere and stored in the material for as long as the product is being used. And at the end of life, you also have several options. So of course, recycling is the best one, but you can also downcycle. And then you can also use the wood as energy when it replaces then the other sources of energy, which are usually fossil based. And wood also has a good strength to mass ratio, good thermal properties, and it's also rather cost effective. So here is just an example comparison for wood and concrete frame. So with wood, we can achieve about 20 to 30% difference in the carbon impacts, depending on which life cycle stages we include. And also it is worth noting smaller scale changes, such as insulation, cladding, and other building parts, since all these small savings and small choices can result in actually quite a significant reduction. So for example, insulation, if you put plastic-based or mineral insulation, it might have have a high carbon footprint that is then reduced significantly when you replace it with cellulose, for example. And then here, yeah, so basically what we just went through. So we received about 30% reduction in the carbon footprint by considering the structural options. And then commandment 4, so choose low carbon products, set clear requirements and select the right suppliers. So once the types of materials have been chosen, it's possible to select within the type. So compare EPDs, choose the best, and so on. So this can be done by setting environmental performance requirements for materials and products. And these should specify minimum carbon performance targets and other measures, such as requiring the use of recycled binders for concrete, for example. And this works effectively for all materials where supply is competitive and suppliers are willing to supply products with improved environmental performance and also publish EPDs that you can then use as a basis for that comparison. So here we are looking at different reinforcement steel producers. So the difference between the best and worst is about 70%, so quite high. So for example, here, some manufacturers may use very fossil heavy manufacturing processes. So if you produce your products with greener energy, for example, you can significantly lower the impacts. And you know, some also some sources. Well, here it says that we have over 90% recycled content. So it basically this recycling part is in order, but this is something also to consider. Okay, well, yeah, here is also about recycled materials. So if you think about recycled materials, so or even the recycled content in your materials, you are again presented with several options for mitigating the carbon footprint of the project. So here with the yellow bars, we have different kinds of concrete. So this is no recycled binders here, but then it is possible to utilize these different these kind of binders that are used to replace part of the cement, because cement is the most carbon intensive part in concrete. So you can use this kind of slag from metallurgy, or you can use, for example, ash from different kinds of processes, and you can also combine both of these to create a material that has the same properties as the baseline, but then has improved properties in terms of carbon footprint. Some other examples here. So we have here steel. So adding recycled steel significantly lowers the carbon footprint again. So here we, for example, have 100% recycled content, and here we have EU average of steel. And then for another example, we have bricks here. So the common bricks would have a carbon footprint of this. And then reclaimed, which is not exactly recycled. So reclaimed would be that it is taken from somewhere, it is cleaned, and then it is reused as it is. So it doesn't need much processing. It has a very, very small carbon footprint compared to the baseline there. Commandment 4, choose low carbon products. So this strategy brought us about 10% saving in the carbon footprint if you compare it to the baseline building. And then commandment 5, optimize the building shape. So achieve a mass reduction with a compact shape. So the more efficient the building shape, the smaller the material quantity. So for example, facilitating the same functionalities with the building space that is as low as possible. So this has an impact on the energy efficiency of the building as well. So as a general rule, a simple shape is more materials and energy efficient. So basically this would be a square building. So if you have a square building, it is the most energy efficient. A more complex building shape, it drives demand for external walls and other facade structures, and also requires additional access corridors. And of course, it is not always possible to create due to different factors such as daylighting, zoning, functional or space distribution requirements, but it does not change the fact that a simpler shape with comparable function and materials means basically lower impacts. So here in our baseline building, the shape was also optimized. So this the example building was a 3-story elongated building instead of the actual building. So the embodied impacts were higher if the building was longer instead of taller. Then Commandment 6, design thinner floor slabs, and this reduces both slab and envelope use. So the horizontal structures are responsible for a big part of the embodied carbon emissions. And unlike the envelope area, the amount of slabs scales linearly with internal area requirements. And also reducing the thickness allows for reducing the envelope height. Slabs also, of course, provide a lot more functions than just being a floor or a ceiling. So there's structural properties, acoustic properties, fire resistant properties, and also they may include piping and other installations within them. But if we manage to reduce the net thickness of slabs, so for example here by 10 centimeters, it reduces the building envelope height correspondingly. So it saves materials from both slabs and walls, and also it saves energy because the conductive loss via the walls is minimized. So if we are looking at some of the innovative technologies that we could use, we have, for example, this delta beam, bubble deck, different kinds of hollow core slabs that incorporate airspace within the slab. So these kinds of changes can reduce the building life cycle embodied impacts by approximately 6% in our case. Having shorter grid spans for columns makes it possible also to use lighter and less steel and cement intensive slabs. And this, of course, has to be balanced against the impact it has on the materials used in the columns, and also the potential impact in the future adaptability of the spaces. So do bear in mind that some types of slab systems have higher impacts, and then of course care should be paid to the overall design here as well. So in all of these cases, of course, a combination of all these different measures, and then you have to look into it as a one entity. But yeah, in our case, we managed to have 6% reduction in the carbon footprint by considering the slab design. Commandment 7 is to do not build separate parking structures, but apply parking policies to shift demand if possible. So parking structures are basically always concrete and will result in quite large amount of embodied carbon, basically regardless of the design. So if the zoning laws allow it, try to reduce the number of parking spots, in particular the underground parking spots and places in parking towers. So it should be handled preferably with open spaces. If you must have parking spaces below the building, there is an option to raise the building so that the building stands on pillars with an open area for parking below the building. So this will save a substantial amount of materials in needless walls around the parking spaces. So this was actually taken into account in our design here. So the initial idea was to have 2 levels below ground for car parking. Then the client decided to remove 1 car park and then handle the rest with, for example, street side parking. And they also reconsidered the remaining car park level by raising the building on pillars. So this removed the retaining walls. It also removed one floor slab and the ground floor slab with its insulation and other structures, and also increase the natural ventilation here. So we had a high reduction in the carbon footprint of the building and also other benefits. This resulted in carbon saving of close to 5%. Commandment 8 is to design for adaptability. So in the future, if I need to do refurbishment, the refurbishment should be as easy as possible. And this also ties very closely to the do not build for short term commandment. So with this kind of design for adaptability, you can considerably increase the service life of the building. So this kind of thing is usually, of course, is very tied to the floor plan configuration. So they may often change. So a good practice would be to use reusable or possibly movable internal walls to the extent that they work for the building function. And also similarly, the electrification that tracks seating arrangements in office buildings is a good choice instead of like embedding the electrification into structures. And also very important is to consider attachments. So instead of mechanical, they should be mechanical instead of chemical. So it's easy to take apart. So it's also this design for deconstruction that works simultaneously. So these kind of design principles are very important for reconsidering the multifunctionality of the building. And here we use these kind of refurbishable wall elements and received a reduction of 4% to the carbon footprint. Then commandment 9, avoid elements that have limited value. So for example, flooring, ceilings, facades. So if your cladding or facade material, for example, provides mainly an aesthetic function, you should consider omitting the layer totally. So if internal ceilings, for example, are not providing, for example, acoustic or fire protection functions, the entire element could be removed. And this will also allow better maintenance, access to installations and cabling. And the same considerations apply also to flooring. So a simple polished concrete floor could be a good option for some types of spaces. But of course, the point here is not to make as barren spaces as possible, but it's to think about the functionality. So how can you add value to your designs by addressing both the functionality and also the aesthetics? So avoid stuff that is only there because it looks nice. And here we got a 4% reduction because of rethinking the internal ceilings and also the facade. And then we avoided the flooring altogether. So that was left basically as concrete. And then commandment 10 is to choose long-lived solutions. So we aim to have a long-lived building, and there we of course need to have long-lived solutions. So if we invest in durable materials, it might be a bit more costly, but it means fewer replacements over time. So over the whole life cycle of the building, they usually pay themselves back, and we don't have to do maintenance or repair or replacement operations. So there is less waste generated, lower life cycle costs, and also less tenant disruption. So what is durable and suitable material for your market varies, of course, depending on the conditions, but the principle is still the same. So this is especially important for carbon-intensive materials such as windows or roofing, but it also applies to finishes, for example, so flooring, wall finishes, and so on. So here we have an example of a material that will last over 60 years. So this was the building's lifetime. So basically we have here the materials and transport, and then we have all this use phase activities here. So maintenance, material replacement is here not needed because this lasts the whole lifetime. So in the end of life, there is this end of life stage and demolition. But then if we have a material that lasts only 40 years, so basically we have a disruption here after manufacturing and transport, and there is some use, of course, here, but then we need to replace it after 40 years. So this is basically added as a double. So there is a manufacturing stage, but then there's also another manufacturing stage, and also all the waste and transport and end-of-life processes related to that are taken into account as well. So here, choosing long-lived solutions resulted in a 3% reduction in carbon footprint. So if we return to this graph here that I showed, so the original plan was to optimize nothing. So this was like a 25-year service life. So already we got a 40% reduction in the carbon footprint. But then if we take this as a new baseline, basically, so we design for 60 years, and we account for good soil conditions, we save a third. Then if we assume 60 years and good soil conditions, we start piling up these different options here. So measures 3 to 10 combined result to about 40% reduction in the baseline, which is a rather good result for optimization. So these are our top 10 commandments, but there are, of course, many, many more. So including many innovative designs and products, or applying some of the following practices. So for example, this design for disassembly, as I did mention already though, and also other circular economy principles. So here is a link also attached to our 10 commandments for circular economy. So be sure to check that out. It is a good practice to buy local materials whenever possible to reduce transport impacts. It's good to ensure structural material strengths are not generalized, but optimized for different uses, because these kind of generalized characteristics, they may usually overestimate. So do make sure that this is like designed for the actual location. It is a good practice to reduce waste through careful specification and buying with take-back agreements, and also consider the longevity of the materials. So if it needs to be replaced frequently, its impacts will be greater. So if you have a material that has a very low carbon footprint, but it needs replacing, as we saw, it will then add up those manufacturing and use and end of life impacts as many times as it needs to be replaced during the lifetime of the building. So if you're interested in refurbishment, you might also want to check the 10 ways to reduce embodied carbon emissions in refurbishment projects. So there is also a link here attached. So a lot of things to do. So we have new construction, circular economy, and also these refurbishments. So a lot of things for you to read. But then if we start applying these practices in an example project, so before we jump into the software, I just remind you how to get access to OneClick LCA. So remember to register and activate your account. So what you would need to do is to go to oneclicklca.com. It says here login, but so you just click that one. And then if you don't have an account yet, click new user, register here, and then you just fill in your information. Remember to activate the name, the user account from the email that you receive, and then you can log into the OneClick LCA platform. And then what you do is that you create a building project and then you activate it. And this happens from this new project activation, as we saw on Monday. So if you did not attend on Monday and you want to check this out again, just go through the recording and it will show you how to do this. And then you remember to enter the license key here as well. Okay, but then let's jump into the software. So we would go here. All right, so I'm logged in already. And then as you recall, this is your main page that shows you all your different projects once you have created your projects. I will just check my notes here so I remember what to say. Okay, and then we are good to go. So I will use the project that we created last time. And then we can just add a design saying, we can say, name this, for example, baseline. And then once we have created our design, we can start adding the materials as we did last time. And this is a very simple example on what you can do with materials. So I will show you, we just want to start adding something here. So in this case, we are starting with our foundations. So we will have, let's say, C50 to 60 concrete. So high strength concrete, let's take basic basic generic data point here, and we are adding, for example, 1,000 cubic meters, and then we save and we see what happens. Okay, so that is our carbon footprint. And then we can go see what the results look like. Let's actually remove this one. Oops. Because we don't need it anymore, but we can just check out the baseline design here. Oh yes, so we get results here, but we don't get them until we fill in all these like mandatory parts. So we need to first input the electricity use. And since this is just a short demonstration, and also if you don't want to calculate energy use, you can always put 0 here. And then we have calculation period that we need to calculate these annualized impacts. So here we can put this 50 years, which is what Levels uses. And then also we need building area, so we can calculate the impacts per square meter as well. So here, for example, our building is 10,000 square meters. Okay. And then once we have saved, we can go back to the project main page. And now with the project main page, we can click this graph and it actually gives us results. So what we can do now is we can start optimizing. So it appears that we can actually use this kind of like concrete that has some recycled content. So we want to create a copy of our design and then call that optimized design. So we just go here and click copy and we can go improved. You can name your designs whichever names you want to, but it's usually good to start with the baseline so you know where you're going. So here we go back to the building materials and we realize that there is actually same kind of concrete, but with more recycled content. So we chose this one, which basically has, well, it has 20% GGBS, but we can choose something that has actually a higher percentage. So this this kind of blast furnace ground granulated slag. So basically it comes from steel manufacturing. So this is a stuff that is left over. So it's a waste product. And waste products tend to have a very small carbon footprint. So if we add those into our mix, it automatically reduces the carbon footprint. Okay, this is not a good example then. So it has some issues here, but we can still maybe use it as a comparison. So we can basically remove that one and just use the quantity for this one. And then we can again save. And once it saves, we can also see here that we are already losing a lot of carbon. So if we go back to the main page, we can see here that our global warming potential went down about 30%. So that is already quite a good result in our optimized design. But then actually a structural engineer comes over and says that we can easily manage with a lower grade concrete. So we again copy and we go lower grade. And then we can go there and change again our materials. So this is something that you can do manually here, or you can also use this replace function as I showed you. We can actually try how it would work. So we would go with C3037, for example, and see if we have some options here. All right, so we have here we had 40% GGBS, and then here we have 40% recycled binders, which is basically a similar kind of concrete. It's just a lower grade. And we can then use this same amount and just replace the data point with another one. And this is, of course, something that you would need to discuss with for example, structural engineers, because they would know what kind of material would be suitable. But here you can see we already got 26% off from our carbon footprint. So we can go back to the main page, and again, we click here graphs, and we can see that our global warming potential, as well as all the other impact factors, are going down. So this is a very good improvement here altogether. And of course, the process is not this easy in real life, because we need to take into account all the other stakeholders as well. But it shows how you can start approaching this carbon footprint mitigation. So consider the material in your choice, consider the recycled content and all these other factors, and then you're pretty much good to go. And then let's go back to here. Okay, and then we will show you the early design stage tool, Carbon Designer. So as mentioned in Monday's session, you do need to start working on it early. So when the earlier you start optimizing, the better, because the cost of changes is much smaller in early stages. So if you start comparing different options here, you're in a good track basically. Because when you start doing a baseline LCAs and then project LCAs, here you have your structural LCA, architectural LCA, and so on. And in this case already we are seeing an increase in the cost of changes, so it's getting more and more difficult to implement those choices that you present. So when you actually start choosing the materials, doing this kind of EPD comparison, for example, it is just that. So you can take your product and you can take your material and you can compare EPDs, but at that point you really cannot say that, hey, instead of this concrete frame building, we should actually make like a steel frame building, because at that point it's not feasible anymore. So your ability to influence the life cycle emissions reduces the further you go. And here is, as mentioned, the highest impact. And here we have Carbon Designer 3D. So it fits into the need basically in this place. So at this point, you don't really have to have any information except for building type, building location, and also the gross floor area. So that can be, of course, an estimate, but once you have those, you can start. And then the further you go, you can also start implementing these other programs. So of course you can use whatever, but these are just examples of some that we have integrations with. So you can, for example, in Revit and in Tekla, you would have this plugin that you can just click and it sends all the data into OneClick LCA. So it makes your life much simpler. So here we would now jump into the Carbon Designer demo. Let's put this a bit. This might be good. All right. So on Monday, we went through the parameters and also add a design. So from here, you can also add designs. So you can just name it and then it will appear here in the list. But here we have also Carbon Designer 3D. And if you click this, it will show you the tool which is enabled for. So on Monday, I showed you that we have here the tools, and the available tools for this license are the levels lifecycle assessment according to the product standard plus A1, and also the levels lifecycle assessment aligning with this product standard plus A2. And as I mentioned, this is the newer version, but the problem here is that as some of the most of the EPDs in the market are still aligned with the plus A1. This means that for this plus A2 assessment, you don't have maybe as much data available. So it will become more and more prominent. And at some point was it 2027, the plus A1 will be, going off the market because the EPDs expire. But until then, either one of these can be used, and at the moment it's still the issue that plus A1 has more data. But because of the two standards, they differ from each other. So there are different impact factors and different ways of calculating. It's not possible to use them simultaneously. So you can choose both of them, but the results may not be comparable, or they might not be actually calculating correctly depending on your source data. So I would suggest that you choose either one. And here I will choose plus A1 because it has more options in Carbon Designer. So I will explain this in just a second. So if we click here, Carbon Designer, and go to the tool, we can create a design. And here it gives us the first step of Carbon Designer. So the first step, of course, it includes entering the name, and this can be our design 1. And here we have a reference building. It's like a model that it uses to create your actual design. So there's several different ones. If you choose the plus A2 aligned Carbon Designer, then you would only have the international reference building here. And this is because there is still data lacking from other areas that would be aligned with the standard plus A2. So here, if you want more options, you would need to choose the plus A1 aligned tool. So here, the Italian and South European reference building would be the most descriptive of a French building. You can also choose international reference building, but there you might need to make some other assumptions. So I would suggest you take this Italian and South European reference building. So this is something that is based on a lot of research, on scientific papers, a lot of discussions with industry leaders, and also construction associations. It's a building basically that describes the typical building in this region. So this is used as a basis behind the model. Here you need to choose the building type. So this one would be, for example, apartment building. There's also here several different ones that you can choose. If you have a multifunctional building, you might want to choose the one that describes it the best, or then you might actually consider dividing it into pieces. So you have one area of building describing an apartment building, and then another area in square meters representing, for example, office building or something like this, and then you can combine those later. But if you are satisfied with using just one, which is most descriptive, then you can use that one. And it is always possible to edit later as well. Here you would put the cross floor area. So, well, we can go with the 3,000 here, I suppose. And also the calculation period. And as you recall, Level's calculation tool uses this 50-year assessment period. And once you have filled in the necessary details, you just click Next. And here you need to define the scope. So what building parts you are including. So we have foundations, ground slab, structure, and with these little arrows, you can see what it entails. So basically, if you want to add everything, then you can, or you can just, take these away, and then it's not added in. And then number of above ground floors. So for example, we have 3, and then underground heated floors. Let's add, for example, 1 unheated. So there's a heated floor and unheated floor, and what's the difference is basically insulation. And then building structure. So here you need to choose what kind of structure your building has. So is it cast in situ concrete, column beam frame, different column spacings, seismicity factors, and then you have also precast concrete and all these other different options. So we are choosing a precast concrete. You can add piling length or piles into your model, but these are not affecting the actual calculations. So these are only for visualization purposes. So we can add, for example, 5 meters. And then you can also select following elements to add to the foundation. So you have a second piling wall, and you have soil stabilization. And again, here you can click for more information in case you're wondering what this actually includes. So here we would add both, for example. Oh, you can only add one. Well, let's put, for example, second piles. And when this is done, you click Next. And then you calculate the geometry. So this is what the reference building in the background does. So it gives you these kind of typical kind of dimensions for this kind of building. And with Carbon Designer, these are always these kind of shoebox buildings. So no matter what you change here, the picture will always be like this. So this is not an actual modeling tool. It is something that is used as a basis for calculating these kind of life cycle impacts. So here you can change these numbers how you want. There's width, depth, internal floor height, and so on. So you can make it like more narrow, more taller, or more elongated if you want, depending on your inputs as well. So how many floors you had and so on. And then you can change these. If you had load-bearing internal walls, you could change the shear, floor thicknesses, and so on. All of these are not changeable or editable. which is unfortunate. For example, this shape efficient factor is something that is planned to be editable in near future. So hopefully we can get it updated soon. So this is something that you would use if you had a more complex shape for the building. And then when you're happy with the dimensions, it will calculate you areas. So this is something that we use in Carbon Designer. So everything is input in areas. So these are also editable. So you can choose to edit amount of walls, for example, or whatever. And when you're happy, just click next. There's apply a template part, but here you cannot really choose anything. This is mostly for people that have a company account that they, create these building templates themselves and then they apply them. But we don't really have much public templates because the Carbon Designer models are in themselves a good estimate. But then you can just skip this part and submit. And it takes a while for calculation. It always takes some time, so be patient. Okay, so now based on our inputs, we have a model. So this is basically when you're starting your designs, you start from the basic information as we input in step 1. So we had the gross floor area, the building type, where it's located, and then in the second step, we defined the frame structure. So here we had precast concrete, and based on our South European reference building, we have a model now ready. So these are, it gives here our carbon footprint by building part, and we can also change it. So we can show it by material. So here we can see the most contributing materials. This is very helpful when you're starting to optimize, because then you can start thinking, okay, so ready mix concrete makes the most. What can I do for that? And this is specific for external walls and floors. So this is like vertical and horizontal structures. What could I do? And then you can choose by classification. So where they are, we can see foundations, upper floors are very carbon intensive. And then we can also see total, but this doesn't really tell you anything until you have like more designs here to compare to. So we can also here activate the carbon view. So this is another, it's like a visualization of where the carbon impacts are. So here we can see that the more red, the more intense. And as usual, it is the horizontal structures. So this is the main point of carbon impacts in typical buildings. So it's basically the floor slabs that make it up. And then when we scroll down, should I put it a bit smaller? Yeah. We have all these building parts and materials separated. So here you can use this to navigate. So you can only show foundations, for example, or you can show all building parts and then you have this list here. And then here it is possible to start editing. So we can, for example, just a second, I'll take my notes again so I don't skip anything important. Just sorry about this. Okay. Yep. So here we should probably start editing. So as we saw here, this is our carbon footprint per material. And it was also here by building part. So we could see, for example, that foundations, well, they're quite heavy, but then actually the floor slabs are the most carbon intensive. So we could navigate to the floor slabs. So we could go to structure, floor slabs, and only have that shown here, or we can of course view them all at the same time. But we can see here that our typical structure here would be a hollow core concrete floor assembly for South Europe. We can either go here, well, we have to go here. So we have to click this edit, and then we have these 3 dots here. And then we have edit, and here we can actually see what the materials are within this particular construction. So we can see that we have a very generic ready-mix concrete here. So we can see 0% recycled binders in cement. We have 80% recycled content rebar. We have glass wool insulation, quite generic, and also self-leveling mortar. So one thing is that we can choose to do this here, material by material. Also here we can adjust thicknesses, add comments, and so on. But we can also go to show these unused resources, and then it gives us a list of what we could do. So one thing we could do is choose a completely other one. So we could choose, for example, a wooden floor, a metal concrete composite decking, or something else. And here, for example, if we would want to change, for example, to CLT floors, we could, for example, do that. So here, let's just take as an example this first option here. So we have 100% of our building impacts or the material impacts here in this hollow core concrete floor slab assembly. So we could, for example, decide that, okay, we want to, 50% of it is actually wood. So we type in percentages because there's no point in using these absolute numbers here. So whenever you input a value, it recalculates it, automatically. So I put input here 50, so it recalculated, and now I have 150% of impacts here or materials, but then I need to change this one as well. And then when you click anything, it recalculates. So this is something that is also in product development. So hopefully soon, maybe during the first half of next year, we will actually be able to edit several points at one. But at this time, it is still working like this. So once you fill in some values, it will recalculate every time. All right, but now I just did this small edit here, and then we can finish editing, and then it has recalculated our floor slabs. This is not something that it's easily seen here, but if you want to, you can see, for example, here that everything that was red is now orange or yellow. So we are actually reducing impacts here. But let's change this actually back so I can show you how this kind of comparison would work. All right, so I set this to 100. This is also something you can do from the 3 dots. So you can set to 0 or set to 100 or do other things. And then you always need to click finish editing once you're done. But when you are making comparisons, you can do up to 4 comparative designs. So what you can do here is you can either copy this one. So it will create another one. So we can call this, for example, optimized design one. And we will have another building here, which is exactly identical. So you can see here all the impacts are same. So here now we could do the same what we did before. So we could actually start adding either change the whole construction or change the materials in a construction. So we could actually go here and check what kind of concretes we could use. So here we have this C3037 with 0 recycled binders. And maybe, well, this is a bit difficult. Maybe there's so many data points here, so maybe it's easier. This is something actually that can be also done when you transfer the design back to the software. So let's just change it into something that we have here as a ready one. We can also find several constructions here. This time it won't show anything else but here, but you can also find, like, I don't know, CLT. It will give you more than they have here, or you can use glulam or any kind of, let's see if we have a bubble deck. Yes, so we could do, for example, this one. And it goes here. And we could put that into 0, no, 100. And then let's see how this would affect our choices. And then, of course, this one would have to be 0. And then we can see that we did some good in our optimization. So we managed to reduce some of the floor slab emissions by changing it into a new construction. And then another thing is that you can compare different structures completely. So you can either always copy these and then just change the elements, but you can also go here, create a design, and it will take you back to step 1. So you can, for example, I don't know, compare what a wooden frame building with the same specs would be like. So this would be like let's just quickly check what it would look like. Yes, the same stuff here, but it is made out of CLT, for example. And then we just click next, and we didn't change here anything, so we can just go with the defaults and then just submit. And again, wait a little bit. So this is once you get to work with it, it may become a bit faster, but it always takes some time to load and to calculate. So that might be sometimes a bit frustrating, but it still works. All right, so here we are comparing our baseline to a similar type of building with load-bearing CLT walls, for example, and we can see that we have reductions, not in foundations or second piling walls, but we have, for example, floor slabs are smaller, and we are missing entirely columns, beams, and shear walls because we have those load-bearing structures. Our balconies, for example, are made of wood, so they are much smaller. And then we have roof slabs and whatever. So it's basically 17% below baseline here. Then when you want to start, oh yes, so one more thing. So all of these different designs, they show up here. So you can choose which one to edit. So for example, here design 2, we can go to, I don't know, structure and edit these parts as necessary so that they are then to your liking. But that's it basically about Carbon Designer 3D. As mentioned, you can only do 4 at the same time, but then you have to change go back to the software and start Carbon Designer again, or you have to remove some of these to continue if you want to. But then when you want to take them into your calculations, you can save design to project. So you can go to the 3 dots here, or you can go choose a design. And you can also go here, save design to project. And also from here, you can copy these designs. So let's do it from here. So I will save this to a project. And then you can either, you need to always have a project ready. So there needs to be a project created before you go to Carbon Designer. You don't have to have a design created, but you need to have a project to use this. And within the project, it will ask you to either overwrite existing data or merge with existing data. All right, so now, yeah, this is not grayed out anymore, so I can choose which one to take. So let's put it to baseline, for example. We can save this one. And then we could also take another of these designs with us if we click the convert another box. But yeah, so this is now saving. And then it says it has been successfully converted, and it automatically takes us back to the project main page. So here, this is what we just did. We can go and check it out. So everything, all the inputs are there. All the materials are here. And because Carbon Designer mainly works with these constructions, these are basically all constructions. If you want to edit these, do make sure to unbundle them and then start editing. But like I mentioned, for example, with the, where was it? The hollow core floor slabs. Oh yes, so we actually changed it into bubble deck, but here if we wanted to start editing, it's actually easier data point by data point within the assessment tool than in Carbon Designer. So in Carbon Designer, it's easiest to work with these constructions. Edit maybe thicknesses if you want, but then if you're actually editing separate material rows, it's maybe easiest to do actually here in the software. When you import from Carbon Designer, if you don't have a design ready that you're incorporating it into, you have to fill in these energy consumptions and calculation periods and building areas. If you are bringing into a ready-made design, then they are already filled in as you have filled them in before. Then now that we have actually like a full design, we can go and check out the results. So what it would actually look like. And this is our results page for levels plus A1. So these are all the different impact categories that we have for levels tool. In the plus A2 aligned version of the tool, we have more of these impact categories as per the standard. So for example, global warming is there separated into 4 different parts. So there's a total, then there's land use and land use change, biogenic, and then fossil. So this global warming potential here, it's very close to the global warming potential fossil that you can find in the plus A2 standard. Here you can see all the life cycle modules that have been filled in. So we have information in all except here use phase. We haven't filled in anything here. And then water use is also blank. And these are now scientific numbers, but if you want to view them as decimals, you can go here to more actions, and here you can choose which ones you want to use. So if you want to work with scientific numbers, that's fine. But if you want to use decimal numbers, you can choose it from here as well. So I just change it to decimals. For me, it's easier to read like that. Here it's also possible to open up these little plus signs here. So for example, here we had A4, and that can be separated into this kind of transport. And then also if we have these second legs added there, you can also view them separately. Here at A5, construction site activities, we have site operations and waste handling, waste transportation, and all of these different things are separated. Sometimes these do not fill in if there is, it depends a bit on the data point. So if there's very generic materials, you might not want have these. And for example, this site waste transportation actually depends on the inputs that you put. So if you know the construction site activities, then these would be filled in as well. And these material wastages are actually based on the default waste factors that we have in the data points. And so on. So here you can also choose which one to check out. Then here we have additional indicators. So describing the use of primary energy of water. These might be helpful in some cases. More site impact. So these are the user inputs. So you basically, if you're using a scenario, then you have nothing here. But if you are using exact data, then you will have numbers here as well. From the details, you can also go and click and see what's there. So here you can get a bit more detailed description of, for example, the building materials. So you can click it open, and it actually shows you all the materials in A1 to A3 stage, and their your own input and their impacts, and also if there's any comments. So they will show here. So you can view them as percentages, or you can view them as numbers. This can be printed, and then there's also more actions, and here you can actually generate different kinds of reports. So you can you can also export used EPDs if you want to. You can generate a Word report, or you can generate a OneClick LCA results report, which looks a bit the same as the one before. So this is the detailed report, and then you can download Excel, and then you can get these results in a format that is easily editable in case you need to do some kind of, for example, special graphs, or you want to do some kind of more advanced calculations. So here, this is what it would look like. So we have a lot of numbers here, separated into sections per resource. Here you have your own inputs, units, and then all these impacts that you want. And they are here for each material used in the calculation. So that might be very helpful. And also, if you scroll down, you find these different sections. Here we have completeness and plausibility checker. So this is something that is based on the internal data of OneClick LCA. So it has these different queries. So for external areas, for example, insulation, roofing. So for example, here, number 1, it flags us with a cross. So it says potential error, but this is actually external areas, so it hasn't been filled in. So that is why there is no materials. So it assesses the credibility of these certain kind of queries and gives them, compares them, the project value against this like given threshold value. So if you want, so this doesn't affect the calculations, it doesn't affect the results in any way, but what you can do is you can use this as a guide to check. So for example, here it says that our roofing bitumen mass is unusual. So we might go back and check out the roofing bitumen and see if we have actually input the actual number, or if there is some other factor that is not correct, or if it's correct, you can always just use this to validate. And then it says user validated, and then your check is basically okay. And because this is created with Carbon Designer, it of course gives us these credible masses for foundations and finishes and glass and vertical masses and so on. So this is something that you can use as like a check once you have filled in everything. Then we have a section called most contributing materials, and this is something that lists 25 of the top emitters basically in your data. So we can see that the most contributing to global warming potential is ready-mix concrete, high strength, and here we can see the impacts cradle to gate, so A1 to A3, and then also the percentage it forms from this stage. So we can see that a third of our impacts come from actually this one material here. So this is also something that you can easily use when you're optimizing. So you can take these most contributing materials and then investigate what kind of alternatives you would have. And to make this even easier, we have this sustainable alternatives here. So if you click it, you will be taken into this list. So it shows you sustainable alternatives in France and also in neighboring countries. So our current option is this, and we can see the carbon intensity cloud here. So it's orange. So basically any one of these would be a better one. So we can investigate if these are something that we could use. If it's something that's not relevant, then that's also has to be, of course, taken into account. And here also we can see the full ranking. So for our specific material, this would be so basically how it compares to all the similar all the materials with similar function and similar basically well, they might not be totally corresponding, but for example for C50 60 concrete it would have to compare to concretes that have the similar kind of characteristics. Okay, and then again we don't have any data here, so let's see if we can get that one open. Either my connection is not very good or there's something other going on here. Let's see if this works, because we should get like a list, like a graph showing the position of these materials compared to all the other ones. But maybe you get the idea. I don't think that it's loading. It's loading, but it's not showing anything. Well, it's a good idea anyway. So if in case you get it working, so that is something to check out. And then also what we can do is we can add to compare. So this ready-mix concrete high strength, we could add it from here to this like comparison function. So what would then happen is that it is, if you scroll all the way up, compare data, it should show here. So yeah, it shows here. And then we get the values here, and then we could go back, find different materials, add them here to compare, and then you would easily get a view of how much impacts there are in different life cycle stages, and then make your decision based on that. It's also possible to compare designs. So here, whenever you in your project, when you make a design, it then shows here. So of course, if you remember, these are the ones that I showed you in relation to that concrete and adding like recycled binders there. So there is nothing but concrete here, so there's no point in comparison. But if we had like a feasible design to compare to, then we could choose it and it would show these kind of like plus minus values here. So either higher impacts or lower impacts in different impact categories. So it's also a good function. And then when we scroll all the way down, we can find the graphs. So different kinds of ones for different indicators. So here we have life cycle stages, classifications, resource types, and also the masses. And we can show here different ones. So this is, I think, one of the most useful because it's so clear. So here you can actually see like the impact, the scale of impact from certain kinds of materials. So here we have, for example, ready-mix concrete, high strength. So this makes up the most, as we saw in the most contributing materials. So this is basically the same. It's just visualized in a different way. We can see the building services make up quite a lot, mortar, ready-mix concrete for external walls and floors, and then reinforcement and so on. And they are also all mentioned here. So you can also go like this if you want to. We have these kind of graphs, tree maps, life cycle stages. So basically whatever you would like. We don't have any operational impacts, so that's why this looks like this. Otherwise, we would have like this annual operational impacts here as well shown. So yeah, a lot of visualizations that you can use. And if there is something that you need but you don't have, you have always the option to export the Excel and then make your own graphs from there. Yeah, I think that was it pretty much from this part. Let's see. We can also, so we already also went through this project main page graph. So here we can also make these different kinds of comparisons. But now I will probably take this one back here. And let's go to presenter view. So as mentioned, we just have these slides showing these different things. So hotspot analysis can be easily made with these different graphs. We can also, we have this link here, how to use the Revit plugin. But if you go to the Help Center, if you are using something else, Solidpre, Tekla, or whatever, ArchiCAD, you can go to the Help Center and you will have information on how to implement that tool in relation to OneClick LCA. So you can do your designs there, and then you can just like send it to OneClick LCA, and it will, calculate your life cycle assessment. We also have some courses at the Academy, so in case you're interested in this a bit more, so there's one for Revit at least, and I think for something else as well. So if that is relevant for you, so you might want to go and check out. So the material comparison that I was trying to show you, this is basically what it looks like. So it would give you the material that you are using, you are comparing against, and then it would give this kind of like, oh no, this is actually, sorry, this is the benchmarking part. So yeah, neighboring countries, everything in database. So how your material would fare against all the other ones, basically. And then to find better products, you could use it to find different products, as I showed. And yes, here to compare products. So this is what it should be looking like. So you add your product there, and then you add other ones that you might want to consider, and then you can add them here, and you can see the impacts per life cycle stage and then how they fare against each other. So for example, here we have okay-ish product stage emissions, but then it has quite a lot of these replacement impacts. And then here we have smaller product stage, a bit smaller replacement or use stage emissions or impacts, but then it has a different end of life requirements. So basically, if it was something that's recyclable, or if it was something that is basically disposed of, if it's hazardous, for example, so then it would also impact these end of life scenarios. And here we have this material or product that has small product stage impacts and then small replacement impacts. So it's basically a durable product and a very good option for this kind of optimization. And then we went through the main page and results page. Oh yes, so this is something that we could show. So here on top, we have this results and benchmarking. So basically, whenever a user calculates or makes an assessment with OneClick LCA, there's this different tool on the background that calculates for internal use in OneClick LCA. So it gathers this kind of like data from all projects, and then from that we can make these embodied carbon benchmarks, and then it just shows how your building is kind of compared to all these other ones. So for example, here we have France, all building types in 2023 Q3. You can choose here what you want to compare against to. So for example, France, we have other ones as well, I'm sure. Offices, warehouses, but not that many actually. With or without the services as well. And then, but because this is it's like an indicatory thing, so it's not an actual result, but it's something that you can check out if you if this is something that would be relevant for you. And then it also gives you this kind of breakdown, embodied carbon by life cycle stage and also by structure. So we can see here also what makes most of the impacts in our product stage. And all of these are, of course, downloadable into images. And then, yeah, so it says here that the unit of results depends on the chosen calculation tool. So here we have the main impact category. So that would be global warming potential. So this is kilos per CO2 equivalent. And then, yes, results populate only when the mandatory data is input. Main page graphs, I think we went through those. Oh, and then of course here you can also choose the appropriate tool and the design, and then you can also navigate from here. So you can go also directly to results here, or you can navigate into different tabs within the calculation here. In case you're importing from Excel, you can bring data in from here. So there's also a very good article in our help center. So import from Excel, you have the templates and everything there, and a very good explanation how to do this. So you don't actually have to like input everything manually, like row by row, but you can just like create this Excel that has all the information that you need. You of course need to format it as explained in the guidance, and then you can use this import tool to bring it in. And also it's possible to copy from data from another design here. And then results page, then we went through the Excel and also the details and the plausibility and the most contributing materials, and then the graphs as well. Okay, so I think that that was it about today. So as a homework, of course, optional, but in case you want to put some more effort into this, you could use Carbon Designer. I hope that you have now taken a look at the OneClick LCA platform, but also go in there and enter the Carbon Designer tool and take a look. What does it require? Model a building with it and see what kind of results you get. And then you can either edit the data in Carbon Designer, create copies and optimize those copies, or you can bring them into the tool and keep applying changes for further reduction of carbon emissions. and also look into alternative materials, alternative products, and so on. Again, a reminder to go to the community in case you have any issues, and even if you don't have issues, go and check it out. And then now we actually have time for questions in case there are any. Let's just open the Q&A. Here I would like to, actually, I forgot to add this to the course page, but we have a short course for Carbon Designer as well, so I will add that there so you can go and check it out in your time. You can also either look at this recording, or you can go and check it out. So if there's any additional information there. There are some special like situations that can also be handled with Carbon Designer. So if you're, well, the multifunctional buildings are one. So in case you are creating a building that has multiple functions, as I understand that your contest description goes. So what you could do is to either, as I mentioned, choose the most representing one and then just alter the quantities of materials in the tool itself, or you can also, choose to alter the building dimensions and geometries and so on. But you can also create two different designs in Carbon Designer. So one for apartment, one for, I don't know, an assembly building or something like this. And then you can bring those both into the same project. So you have two designs basically. And then you can either work with them like this, or you can also merge them into together. So you have the both of them in the same design. So this way, it's just, a question of like keeping track of what goes where. But basically, as life cycle assessment, this is basically just materials and material emissions. It doesn't really require that much knowledge on like where exactly this impact is taking place, but it's just so that you can yourself keep track of it. Yeah, and I'm thinking if I have any more good tips to give, but I think that was most of it. So in case there is no questions, I think that we can call it a wrap from today. So I thank everyone who has been joining, and remind you that this recording and the slides will go to the Academy course page tomorrow, and they will remain in your use until the end of the contest in next year, June. So I think that was it, and thank you, and have a nice rest of the week. So hope to see you at some point later. And I will now stop recording and end the meeting. So thank you.